Hello and welcome back to the Dragonfly Daily. I am your host, Mike Marsh. I am the product manager of Dragonfly at ORS. You can follow me at Dragonfly Wizard on Twitter. You can also connect with me on LinkedIn or ResearchGate. But most importantly of all, follow us on YouTube. Find that orss.ca/YTP2. That'll take you to the playlist for all of the Dragonfly Dailies. While there, you can browse the channel and find the other video content. Make sure and subscribe and make sure and give us a like. If you are watching this video on YouTube right now, you're not watching live, hit the subscribe button, turn it from red to gray, and that way you will be notified whenever there's new content available. Today's lesson 33, is 3D rendering, and we are doing it with Dragonfly 2020.1. So today is the first lesson we're using the 2020.1 release. So more specifically, lesson 33, 3D rendering with Dragonfly, we are using the 2020.1 release candidate 1. So you will find that online if you go to theobjects.com/dragonfly/earlyaccess.html. You will find this information where you can download. So as of right now and as of the last 2 or 3 hours, the link is dead. We're waiting on the internet service provider to restore the link. Should be back up within the next hour. If you're watching this on YouTube, it should already be up for you. Now, the lesson is 3D rendering. We're going to look at 3D rendering. We haven't really ever discussed 3D rendering in Dragonfly 4.1 or, of course, 2020.1. So we're going to have a chance to discuss that now. I have in front of me Dragonfly 2020.1, the release candidate, or something marked as beta build 788. Now, what we'll do is I have in preferences 3D settings. I currently have it set to use the legacy engine. So the behavior we'll look at for the first maybe 5 minutes, we'll be using the same rendering engine that you have access to in 4.1. And then we will switch over to the new rendering engine so you can see some of the differences in different behaviors. So I'm going to open up some data. So I'm going to open up my organizer. Let's see, is Dragonfly in the foreground? Shift O. Oh, I thought that would open up my organizer. Let's try again. Open the organizer. Here it is down here. Now, in the organizer, I'm going to do a search, and I'm going to search for Viz Demo, where I have some data sets here that are ready to go. We're going to look at the Denim data set first. You guys may remember this data set, which comes to us from Rigaku, from Ayatakasa and colleagues at Rigaku Americas. This data set is an XRM, or an X-ray microscopy reconstruction of denim fiber. I'm going to double click in this panel to go full screen. Now, as I mentioned earlier, I am using the rendering engine in 4.1. Now, in this data set, we can adjust the on-screen visualization in the 3D window the same way we have done in the 2D window. I can adjust the window level settings to try and enhance the contrast and get the brightness just right. So I have options to try and visualize the fibers. You can see what I'm seeing here. So I've got some fibers that are slightly on average darker intensity and slightly on average brighter intensity. If I click on the image channel itself, we will see some properties over here. We'll see 3D presets. So there are different presets that enable different features of the visualization. Now, when we are trying to deal with 3D visualization in Dragonfly, the behavior is really being dictated by 3 different panels. So of course, the window leveling panel is at play. We also have the scene view properties panel, which is affecting our visualization. So in the scene view properties, we have a light source, and we have other features such as orthographic projection. We also have the features and details of the current lighting model. Now we do have use lighting turned on, so that is enabled. So number 1, the window leveling. Number 2, scene view properties. And number 3, the property panels for the image channel. So you see 3D presets and 3D settings. There are different presets that have been designed. So if I choose plastic material, I can see some effects that are enabled. Basically, when I choose a different preset here, it's basically setting different parameters for 3D settings and different parameters for the lighting and scene view properties. So someone has designed a set of parameters and called that plastic. Here's a different set of parameters and called that concrete, etc. And so these are taking advantage of different lighting. Sometimes they have focus enabled, etc. You can, in fact, make your own preset in Dragonfly 4.1 or in Dragonfly 2020.1. So these different presets can give you different lighting effects to try and create a different on-screen view. Now, the rendering engine allows you to visualize your data, but it does have limitations, and some of those limitations are overcome and extended with the new rendering engine. Now, this is one data set we're looking at. This is the Denim data set we're looking at with 4.1. I'm going to look at one more data set with 4.1. Then we're going to switch the rendering engine to 2020 20.1. The other data set I'm going to look at is this automotive part. I'm going to drag part into my workspace, and we're going to turn off Denim and turn on part. All right, so here is a data set, and this is probably an aluminum casting, and we can see features. So when we can adjust the lighting model, we can adjust the shadow strength, the shadow precision, we can adjust the lighting, which could be a diffuse lighting, which will you'll see the effect here, or it could be a specular lighting, which can make it a little more shiny. You see the little shininess right there. You also see that when the object is rotated or translated, it does downsample a little bit to accelerate the experience. So here is an automotive part demonstrated with the first generation rendering engine. Now, what I will do is I will now switch to the new rendering engine. I'm going to go to 3D settings in my preferences. I'm going to click the checkbox for use new rendering engine. There are some options here. I'm going to leave these as default, which is the grayscale default preset and the best quality interactivity. I am going to click break during motion. I'm going to show you what that means in just a minute. I'm going to click OK. Now the rendering engine switching from the legacy engine to the next gen engine does not happen right away. Gosh, it feels like it happens right away. Maybe someone updated it. I think I'm supposed to create a new session, so I'm going to do that just in case. This is going to restart Dragonfly and make sure that I have the new rendering engine loaded. Now I am going to go back to open the organizer, and I'm going to drag this part in. So now I have this part. I can double click. And what we see now is, again, the visualization properties will be defined by the window level, by the scene view properties. Let's turn this off. Let's expand this. And by the properties over here in 3D presets and 3D settings. We see more settings and more options now that we have enabled the new rendering engine. So we have different capabilities. Now the first thing I'm going to draw your attention to is we have refactored the 3D rendering engine in many ways, and one thing to note is the window leveling is treated differently. Now you still have a lookup table that maps the intensities of your image onto colors and transparencies. You can always come over here and edit the lookup table. So you see this lookup table is a 2-node lookup table going from black to white with a linear grayscale ramp. So you can edit this if you want, and it'll change the behavior on screen. However, unlike 2D viewing and unlike the behavior before, you will not have the same behavior of the window, which is to say, the left bar is basically what we can consider a high-pass filter. Everything to the left of the left bar will be rendered as transparent. The right bar actually has no behavior on the view. So the intensity mapping will go directly by the lookup table, and this left bar in 2020.1 just functions as a way of making everything that is very low intensity transparent. So we have all of this that we don't want to see, so we can drag it to the right. Now, I mentioned that we have different presets. 2020.1 has a few presets already, so if I click Cast Aluminum, now I can see what this part looks like. Now, I'm going to click this checkbox for break during motion. What that means is if I zoom in, when I am dragging the mouse, it is in an accelerated mode, and as soon as I release the mouse, it takes a moment and then renders the scene. If it takes maybe 200 or 500 milliseconds, but I start dragging the mouse again, then break means it will stop the rendering so it can be interactive. So break means don't wait for it to finish rendering. If I drag the mouse, I want it to render. So now we're looking at this cast aluminum settings, and we can see there are these options for specular, which you see how much less shiny it is, or I can make it more shiny. I say shiny. The specular effect is really the reflection of the specular light source, as you see there. We can make the whole thing shinier or less shiny with this slider. We also have this solidity panel, which I think you'll notice changes the opacity in some ways. If you're looking at a sample and you want to be able to see through it, you want to be able to see the defects, you can click Edge Contrast. So now we can sort of see where the defects are inside the sample, because we're not rendering the sample as opaque, we're just accelerating, or I should say accentuating the edges so that we can see through. So that is the Edge Contrast effect. So with this, you have different behaviors. So cast aluminum is turning on this enable focus, it's turning on a light source, it's turning on different shadow settings, and it's turning on filtered gradient, but it's leaving other options off. So I can walk you through a few of these options. Median applies a real-time filtering on the graphics card, so it will smooth the data a little bit by applying a median filter. And that happens on the graphics card. It doesn't change your data in memory. Unsharp is a sharpening filter, which will work to sharpen the edges on your data set. And so if you are trying to create your image and make it look sharper, that is an option. However, I know it says unsharp. That's just from the image processing literature. It's called an unsharp mask, but it is the goal is to make your object look sharper. These options here, tone mapping and filtered gradient. So, I'm sorry, before I move on. So I just told you this is an option to make your object look sharper. Before you do that and have issues, I want to draw your attention to the focus effect in the Dragonfly rendering engine. This is enabled in 4.1 and in 2020.1. The focus effect allows you to draw the viewer's attention to a specific focal plane or to a narrow focal slab. If I turn it off, then the whole object should be in focus. If I turn it on, I'm going to turn off autofocus and I'm going to make the depth of field really short. So you see how blurry the image is. This is the focal distance, so I can set it distant or I can bring it near, and so you can see now this is what is in focus. Then I can make it a slightly deeper focal plane. I could reduce the strength of the focus. Now you see in the distance it's very blurry or somewhat blurry. In the foreground it's a little bit blurry, but this is very sharp. If you're trying to create a rendering and you're trying to draw your user's attention to a specific area, you can use focus. If you don't want to set the focal distance, you can use autofocus, and it's basically going to set the focal plane somewhere near the middle of the object that you have being rendered. So I don't want you to have focus enabled and then come over here and try and turn on sharp to get it sharpening, because no matter how much sharpening you have, it's still intentionally being blurred in the distance when you have the focus effect. So you have that bokeh. If you're a photographer, you'll know the term of having that out of plane blurring. Now, tone mapping allows you to remap the lookup table in a slightly different way to enhance the dynamic range. So sometimes when you turn on tone mapping, it will effectively give you a little bit more dynamic range in what you're rendering. We'll see that on another data set. Filtered gradient applies a filter to the image gradient, which is used during the lighting source. So you can, or during the evaluation of the lighting model, so you can see a slight difference in the lighting for most visuals when you turn on filtered gradient. High quality makes the graphics card effectively do an extra pass. It takes it a little bit longer, but you can see the image is sharper, or I should say maybe higher quality. Specular boost, we talked about specular is the how the specular light is reflected, and so with specular boost you can see there are lots of little shiny light reflections once I've turned on specular boost. So this has shown us some of the features. Now there is the lighting source over here, so we can change the lighting source for our 3D rendering. We can also change the strength of the shadows, and we can change the shadow opacity. So the shadows have a certain strength in how they're being cast, and you can observe that by toggling this. So you can sort of see it's a bit of a blurry edge, or it could be a very sharp edge on the shadows. And then the opacity, the shadows could be very high opaque or very low opaque. So you can cast the shadows without completely obscuring what you're looking at. Now, one other effect I want to mention in the next generation rendering engine is, let me turn off high quality for a moment. One other effect is this virtual floor. Let's see if that is turned on and working. Okay, so this will take your object and it will create a floor on one of the planes. If your object is askew with all of the planes, then you won't be able to get a very good floor. But the whole idea of a floor is if you want to cast the shadow onto something, then you can create a floor, and then you have something to cast the shadow on, because and this is just a visualization. It's just eye candy if you want some target for the shadows. The floor you get will depend on where the object is oriented when you turn on the floor. So you can see I have a different floor now that the object is positioned here. So that's another feature that's new in the 2020.1 rendering engine. Now, we've looked at the part before with the legacy engine and with the new engine. Now I'm going to remove the part, and I'm going to go back to my project organizer. Whoops, that's not it. And let's click this button for search, and we'll again go back to VisDemo. And this time I will grab the Denim sample so we can look at that one again. And we'll pull this over here into our workspace. And we'll turn off our floor. And so I can adjust which pixels are rendered as transparent. And just a reminder, this will not have an effect on the rendering. Now, I can use different presets over here, and you can experiment with the different presets. So we could say, does the cast aluminum help this data set? Turns out that some of these you should experiment and play. This one is called Mummy, but you may like the effect that it has. And so also I want to draw your attention to the gamma function here. The data can be very sensitive to the gamma function. So here I am adjusting the gamma function by bringing it down to 0.2. If I bring it up to 2.0, we'll see different behavior, etc. Now, if I'm trying, we can already see I've got a sharper view of the fibers than I had before, and maybe use the median and use high quality. And we can get a nice rendering. Of course, some of these presets will enable the focus. If you don't want the blurring, then you can turn off the focus, or you can turn off the autofocus and then set the focal distance to whatever it is you're trying to enhance. So that's just a look at the Denim data. Now I want to pull up a couple other data sets to show you during this demo. So let's return again to the organizer. And let's have a look at let's see what we have here. Let's look at a bone data set. So this is a mouse femur. This comes from, thank you to Rob Goulet and Carl Jepsen at the University of Michigan, and Carl Jepsen's group at the Orthopedic Research Laboratory there for contributing this data. So we see here that we have a long bone, a femur of a mouse. And one of the presets we have over here is for bones, actually two of the presets. So this is, so sometimes you'll have to adjust it before you get a full refresh. So now we see that we have a lookup table and we have lighting effects that are designed to make an enhanced rendering of bone. So there are two presets here. We could choose bones 2 and see how we like that one, or bones 1. And whenever you change your presets, if you want, you can make a new preset and save it so that it can be used later. So here we're just looking at a more photorealistic rendering of bone. You can still adjust all of the shadows, or you could use the virtual floor effect we looked at before, if you think that's going to make a more useful rendering or better eye candy or for your presentation purposes. The floor itself is based on the spatial extent of your image matrix. So if you have a very large image matrix, it'll make a larger floor. You don't have any controls over the floor, just over when you click the button, it will enable a floor based on the current viewing angle. But you can see if you wanted to change this, you can affect it that way. If you were to clip inside the bone, so if I would come over here and I turn on the clip box and maybe grab the clip box. Now I am going to turn off the virtual floor. I just want to mention that when you're visualizing in here, the shadows are just as effective inside the sample as they are outside the sample. So if you have the shadows turned on, it will be sensitive. So if you're looking around in the trabecular bone and you want more opaque shadows and you want stronger shadows, then you can have all of that turned on. It will be sensitive to the light source. Now, I have a couple of more data sets, so I'm going to look at a biological sample that is from SEM. So I think everything so far has been CT or micro CT. Let's pull up an SEM data set. This data set is a little bit large, so it may take me a moment to open. Let's go to open the organizer, and we'll pull up VisDemo again. And I'm going to grab this. It is a serial block face, or a 3-view data set that comes from Angel Paredes at the FDA. So Angel and I collaborated on this some time ago, and Angel actually published a paper and has made all of these data available to any collaborators. So I wish I had the citation handy, but if you look up Angel Paredes and rat neurons or ketamine, you'll find this paper. I'm going to pull in these 3 ROIs. There's the mitochondria, there's the nucleus, there's the cytosol, and now I'm going to close the organizer. So we have a 3D block. It's a pretty large data set of mouse neurons, and we can experiment with these different ones. So we could look at the what's the first one? The mummy it's called anthropogenic. I'm not sure why, but we could look at the mummy, and that creates a lot of solidity and a lot of contrast. If we like that, we can keep it. We could experiment and just go back to bones, for example, and see how we like that. So this has a lot of texture we see in the image. Now I'm going to turn on some of the ROIs. If we look at it in 2D, you can see we have all of these processes in the periphery, and then we have one large cell body in the middle. You can see the cytosol and the nucleus and the mitochondria. So that's what they look like. I'm going to visualize them in 3D. So I've turned on the cytosol, and I'll turn on the nucleus and the mitochondria. And so now we have this 3D visualization of the serial block-based data. Looks like I have the focus enabled. I'm going to shore up the focal distance to be sharper in the foreground. Now there's also this global volume opacity, and this is useful when you have ROIs enabled. So this will reduce the volume of all of your objects except those objects that are modulated by an ROI. So the intensity under the ROI is going to be persistent. So I can reduce the opacity a little bit and let it sharpen up. So here we have all of this electron microscopy image intensity surrounding the segmented cell. Now I may come over on the cytosol ROI, and I may reduce its highlight intensity. So I can create a nice rendering that shows what my 3D SEM images look like. Now I'm going to continue to bring down the global intensity. So here is the shape of this particular cell. If I further want to bring down the cytosol intensity, I can. And now we see all of the intensity inside the cell, plus we see the nucleus, and we see the mitochondria. If I further take cytosol and say I want to take all of that labeled data and bring its intensity down, now we have a decent rendering of the nucleus and the mitochondria with sort of this hazy effect. All of the electron stain inside the cell is creating some bit of opacity, and everything outside, of course, is reduced by that. I can further bring this down. And so now we have a nice rendering, and I can still affect the opacity of the intensity of the mitochondria or the nucleus, and then we can still adjust the window leveling, and we can adjust the autofocus, and we can make a very nice rendering of our data. So that was the biological example. I'm going to delete all of that and look at the time. It is 8:23. Now I'm going to pull up my organizer because I think I'm going to go to one more data. So I'm going to open up the organizer and do the search for Viz demo once more. Now, we looked at the bone, and we looked at the denim and the FDA and the automotive part. There are two left. We're not going to bother looking at the sand pack. It's the same dry sand pack we looked at in earlier lessons, but it's modulated by a multi-ROI instead of ROIs. I will pull up this data set. It's pretty slow, so give me a moment to load the data and then load the ROIs and visualize. It's a nice data set with a demanding segmentation that is much easier to interpret after you have pulled everything in. Let's see, I think this is a multi-ROI, and we might just use that instead of using the individual ROIs. So this data set is a silicon carbide ceramic matrix composite. The data were collected by Ali Badran and his advisor, David Marshall at the University of Colorado. The data were collected at the Advanced Light Source at Berkeley National Lab on beamline.8.3.1, is it? With the help of Dula Parkinson. So thank you to Ali and Dave and Dula for these high quality data. If I double click and pull this up, then we can look at the data. So here we have these data, and they're very low contrast. This is a silicon carbide matrix. These are silicon carbide fibers. Here are some pores. Here are some pores. This silicon carbide matrix has very similar attenuation to this exterior barrier coating, but the multi-ROI does the segmentation and tells you where all the phases are. Now, in this release candidate, there is a bug that sometimes causes the rendering to glitch, and you have to force a refresh. So what I'm going to do is I'm going to just choose, we'll just go back to the mummy anthropogenic and see if we can trigger a reset on the data. So let's turn off the visibility, turn it back on, and oh, it's not coming up at all. Well, that's disappointing. Well, will we try once more? Maybe we'll have to skip this data set. So we'll just clear out the session and make a new session, and we'll pull it up in just a minute. I'll go ahead and take some questions while those data load. So I am going to initiate the loading of the data, but in case it doesn't work, I'll move on to some questions. So I'm going to go to open the organizer and pull the data in again and pull the multi-ROI. Now I'm going to pull up the questions and answers, and let's see what we have here. Oh, we do have the 3D rendering working already. That's great. So first question is, where will I be able to download? And someone has already answered that. You can go to early access to download that. The next question, what is the advantage of the new window leveling high pass? For data I work with, I benefit from moving both the left and right threshold and not having to change the LUT to get results I want. So I'm a bit confused. I do like the new renderings. Well, I do appreciate that this creates an extra burden on you. I don't have enough time to really get into the explanation, but it creates a better use of the lookup table. And right now, I recognize that it's a little difficult to have to manage the window leveling on this widget over here, the window leveling, and to manage this. All I can say is, in the summer, we'll release another version of Dragonfly, and all of these LUT editor tools will be integrated over here. So you will be able to get exactly the effect you want. So if you're trying to, change these nodes, you'll be able to do that directly here. So while this won't have an effect, you will see exactly how this ramp and these colors map directly onto your histogram. So if you were doing this, you would instead just drag down here or create a window shade effect. So I apologize if that's inconvenient. It's part of an incremental improvement, and it's getting us in the direction we need to do to have a better, more robust, more predictable rendering engine. Now, I will go back to the questions in a minute. I am going to see if I can turn on a rendering here. So let's try, we'll just try bones for now. And what I'll do is we'll adjust this and recall that I can use a middle mouse drag to zoom in. Sorry, not a middle mouse drag, a middle wheel up and down to zoom in on the histogram. So now we have a very texture-rich visualization of the ceramic matrix composite. I do want to adjust the lighting so we're not missing everything. So we have a very texture-rich, and then I could turn on the multi-ROI. So if I click the visibility, it's going to turn it on for the 2D views. Let's see if I can position the mouse right there. It's going to turn on for the 2D views, then we'll have to turn it on separately for the 3D views. Now, while I wait on that, I'm going to go ahead and take the next question. Does the new engine drastically change the minimum requirements for the software? It does not drastically change. You will have slower performance with the new rendering engine than you did with the legacy engine, which is one of the reasons we enable you to continue to use the legacy engine, and that is set in preferences. The next question, is it possible to somehow direct where the virtual floor will be positioned, or can you add some object to add as a floor, just in case the automatically generated floor is in a very odd place? Well, you could use all of the Dragonfly tools you know to create your own object, or you could load two objects so that you have something to cast your shadow on. But the virtual floor here has no options or parameters. It's just when you turn it on, it will position a single floor. If you turn it off, and you rotate your object and turn it on, it'll create the floor in a slightly different position. Okay, so this should be rendering. Okay, there it is. And now we see the effect of this. Let's double click to go full screen and wait for it. Okay, so now we see, oh, I double clicked twice. Too bad. Let's double click again. And what you can see over here is something else I want to draw your attention to. So we have the image channel and we have the multi-ROI. Multi-ROIs have changed for 2020.1, and we'll get into this briefly in tomorrow's lesson. But you see that now every object of the multi-ROI, or I should say every label of the multi-ROI, you can toggle its visibility and you can toggle its color directly in the property panel. So this has 4, so I could turn off the visibility of the pores, and I could turn off the visibility of the EBC, and in this data set, in this case, we just have to wait for the rendering engine to catch up because this data set is so taxing on my graphics card. But you do have the ability to, so now we've turned off the EBC, we've turned off the pores, and now I will turn off the visibility of the EBC, and we'll be left, of course, with the silicon carbide matrix and the silicon carbide fibers. Now, While I wait for that rendering to update, I will go on to the next question. The next question is, this is amazing. Can I use this for my publication now, or would you rather I wait for 2020 to be ready? Well, no, you can download the release candidate and do anything you want with it. So if you want to make publication quality figures for your manuscript, by all means, go ahead and do that. In fact, let's take a look over and see if this link has refreshed. Still not working. It will come up today, and this happens sometimes with our download links. We haven't gotten all of the kinks worked out with our internet service provider. But I am using the same version that was live. If you happen to download it yesterday, say after about 4 p.m. Eastern time, if you happen to download it yesterday and you got it, then you'll using the same version because I downloaded this yesterday. So what I have over here is I was just going to drag the global volume opacity down, and now I have this new rendering, and it has different effects because I'm using, what did I choose? Sand. I could choose one of the others. I could choose, maybe I chose bone. I don't remember. But you get the idea. So we can adjust the shadowing intensity and get a very high quality, high impact rendering. This data set's more taxing, so you can see as after I release the mouse, it takes it, maybe 1,000 or 1,500 milliseconds before it updates. But I can rotate in real time, and then that's the idea, is it downgrades the resolution while you do the rotation, and then as soon as you release, it refreshes. Okay, now let's go on to the next question. Is it possible the link is broken? Yes, it is, and it will be restored shortly. Can I set preferences to use best quality when trying to do a movie and a lower quality for when I just want to move things around the scene? Yes, you can. So you can always come over here and switch from best quality to something like speed, and that will didn't make things faster for me in this case. Let's see. I switched speed. Okay, now it's very, very fast as I move it around, but it is still going back to a high quality after I release the mouse. So there's also balanced, so you can experiment with this. But after you set up your different keyframes and then you hit render, it is going to move the model for every frame. It's going to wait for the frame to render and capture the screenshot and move on. So you will get the high quality movie when you make your animation. Do you need more GPU RAM when using volume rendering and multiple ROIs? How much? That's a good question. In 4.1, our RAM allocation was less sophisticated, and if your object and your model was too big to fit in memory, then we would do downsampling, and so the model would look lower resolution than it actually was. What we're doing here is we are, in most cases, using a much higher resolution sampling of the data, but it has to process it in chunks, which is why sometimes rendering takes a second or 500 milliseconds, because it's swapping out memory in order to give you the full sampling and full high resolution rendering. So there are it does have a trade-off. Getting this higher resolution rendering does reduce the performance, but it still is able to get much better use out of your GPU RAM. Next question. I've had similar issues with 2020.1. When I load a multi-ROI in 3D, the view of the data occasionally becomes black. Seems to be specific to the ROI. Is this the same bug? Is it fixable? So let's see. The only issue I had here was it was slow to respond. We did have before I did a new session, when I loaded up this data set, wouldn't load at all, so I had to do a new session. I don't think I saw the issue you're describing, or maybe I've just already forgotten it. If you want to send an email to support@theobjects.com, we can make sure that the bug you're identifying has been flagged and is either fixed or on the way to being fixed. Okay, that looks like that is all the questions for today, so thank you for your attention. I hope that we get this up and running for you very soon so that you can download. Still down. It will be up, and it'll be up, gosh, it usually takes them about an hour and a half to respond, and we only logged the issue about 45 minutes ago. So it should be up very shortly, and you'll be able to download this. If you're one of the lucky few that downloaded it yesterday evening when the link was working, then you can already start and use this. So that is it for today's lesson. Tomorrow we will turn to, I believe, the segmentation wizard, another new feature in 2020.1. And if you happen to see the CCEM lecture about 2.5 weeks ago, then you got a taste of the segmentation wizard. So that's it for today. Thank you for your attention, and everyone stay healthy and look forward to seeing you tomorrow. Take care. Bye-bye.